We now have a late addition to our panel, one we're delighted to have secured, Monica Donaldson-Balan. Monica is a building performance consultant and architect and a sustainability lead at Mott MacDonald, the global engineering consultancy. Monica will be presenting the path to zero carbon heat, a subject in which she is very well versed. Monica was involved in the technical feasibility programme, assessing hydrogen and the impact of low carbon heat and energy efficiency measures in Scotland, and was also the Heat Workstream Lead for the heat decarbonisation work of the Infrastructure Industry Net Zero Coalition. Now, to share those findings, Monica, over to you.
Thank you, Pippa, and hello, everyone. So I'm going to talk today about the different pathways to achieve heat decarbonisation and some of the challenges and solutions associated with these pathways. So we clearly, all of us think that that heat decarbonisation is going to be a challenge as we're attending this webinar. The question is, why is that? Well, I think scale is part of it, and we can see a graph here showing that in 2016, or about 40% of emissions in the UK were associated with heat, out of which about 25% were connected to buildings. So this is a big scale that we're looking at. But I think there's a second part of this issue as well, is the fact that there is uncertainty. There isn't just one straightforward way that we can take in order to decarbonize heat, and that, as I said, produces uncertainty in the industry. So in order to move forward the debate, we developed a series of roadmaps for the delivery of infrastructure required for 3 different pathways for heat decarbonization. This work was undertaken by the Net Zero Infrastructure Industry Coalition, which is a coalition that was set up by Mott MacDonald, and it brings together organizations with infrastructure experience. And the idea is that we can help advise government on how we can best achieve net zero for infrastructure. The roadmaps themselves, they were developed by the working group that has a very broad experience and wide range of experience in delivering infrastructure. And also we had on our steering group based the CCC and CBI. So I mentioned before that there's uncertainty in achieving and that multiple ways in we can decarbonize heat. And we selected 3 separate scenarios. We based these scenarios on research that was undertaken for the previous CCC Net Zero report. And we chose on purpose 2 of them at the very ends of the scale. So in one of them, we would have a full replacement with electric system. On the very other end of the spectrum, we would change all natural gas with a green gas. In this particular case, we looked at hydrogen. And then we also looked at a hybrid scenario, with the hybrid scenario sitting closer to the fully electrified one. We can achieve any of these scenarios in a centralized or a decentralized way, depending on how we propose to implement solutions. And for the purpose of this work, we looked at the centralized version because we are interested to understand the implications for the infrastructure. So what did we do as part of this work? Well, we developed the infrastructure roadmaps, looking at the entire energy system, all the way from energy production to end users. And we mapped the actions and milestones from now to 2050 that need to be met in order to decarbonize heat for all 3 scenarios. We weren't trying to give a definite answer, but we just wanted to move the conversation forward. And you can see in our report some of the technical details behind the roadmaps themselves and the roadmaps themselves. So over the next few minutes, I'm going to take you over these 3 pathways and show you how we expect to see the UK in 2050, and then also what are some of the challenges and solutions for this. So we have now the electrification scenario, as we expect the UK in 2050. We are looking at a very simplified version of the entire energy system. On the right-hand side of the screen, we see end users and what energy mix we expect. And on the left-hand of the screen, we see the infrastructure that we need to support this. So full electrification 2050, we now have almost 23 million heat pumps in people's homes. And we also have over 20 million energy efficiency packages. Now, a lot of these interventions, not for all buildings, but some of the buildings, they're going to be quite complex. Some of them can be intrusive, not all of them, but I'm thinking potentially some of the energy efficiency might change external appearance. So we need to make sure we tackle this early on, that we have the right supply chain in place and the right skill set in order to successfully deliver the installation. And that's just on the user side. I think a couple of the speakers alluded to that peak demand. So what happens now if everyone's on heat pumps? The electric system basically needs to peak that to meet that winter load. In this specific scenario, we have about 400 gigawatts of total electricity generation capacity. So that number can be brought down with different, more flexibility in the system, more targeted energy efficiency measures. But the idea that compared to what we have today, which is just about 100 gigawatts of generation capacity, it will be a significant increase. So that means that in the years to come, we will have to deploy at an increasing rate a lot of plant to meet this generation capacity. And that is just on the generation side. Now we need to also understand what happens with the networks. So we have a transmission and distribution network for electricity. In terms of the transmission network, because in part we have a much better energy mix with about 200 gigawatts of wind and solar compared to just under 40 gigawatts today. So, and a lot of that is for the UK probably going to be made out of wind turbines that are going to be installed away from demand centers. We're going to need that transmission system probably to have, not probably, we will require capacity upgrades. We think this is a challenging task, but achievable with the right steps. So that's the transmission network, but we also have distribution networks. So that's the actual network that brings electricity to our buildings. And for the distribution network, it's going to be a sort of a twofold problem because we're going to have electric vehicles as well as heat pumps. Looking at this in more detail, we actually think that in the 2020s, as long as we enable both end users and distribution network operators to take advantage of smart systems and demand-side management, that we won't need significant infrastructure reinforcements. However, as we approach the 2030s and we install more and more heat pumps and we have more EVs, we will need more coordinated upgrades on the distribution network as well. We can see that this is challenging but doable, and it's the importance of looking at the entire energy system and understanding the changes across it. The second scenario is a hydrogen-based one, and this is a very different version of the UK in 2050. We have 50 million boilers, hydrogen boilers. Now we can see them in yellow on the diagram. But before we get to the boilers, the hydrogen pathway has a very unique challenge, and it's the fact that we still need to prove the full feasibility of hydrogen use for heating buildings. There are a lot of projects that are currently looking at that. So we have Hyperheat, we have H100, but they need to be completed in the next few years and understand all the implications. We also need to be able to prove that both the technical and the economic feasibility of hydrogen production, particularly when we're talking about carbon capture and storage. And once this is done, we now have, let's assume we have proven the feasibility. It's the next steps of the rollout and actually getting those 50 million boilers installed. So that will require quite a high conversion rate. So we could potentially look at about 1 million conversions a year. And similar to the heat pumps, you require planning and coordination and a high number of trained engineers and installers. And again, similar to the electrification scenario, we have now the end users, the system in the end user in the buildings, but then we need to get the hydrogen to the buildings. In this case, we're looking at the gas grids, and the hydrogen, we will need a hydrogen transmission grid, and we can probably repurpose parts of the existing gas grid, but we might also need to build new infrastructure. And this depending on both what type of architecture we'll choose for the whole system, and also research that is ongoing. And depending on that, the size of the challenge will differ. And sort of the last step in the puzzle is the fact that we also need to produce the hydrogen. So we can produce hydrogen in a variety of ways. We can look at electrolysis with renewable energy, and we can also look at reforming, which basically takes natural gas and it splits it to get hydrogen. The issue with this is that we have CO2 emissions, so we need to couple it with carbon capture and storage. However, even that probably will not get us to net zero. Now, there are different ways, as I said, we can produce hydrogen, but regardless of the production method, the scale of meeting this over 100 gigawatts of production capacity compared to the very little that we produce today for industrial purposes is probably without historical precedent, and it needs to be started as soon as possible if that is the pathway we're taking. Because the other sort of the grand sort of looking at the entire hydrogen pathway is the fact that all of these various projects that I've mentioned, they're national scale infrastructure projects, and they need to be developed in such a way in which they're coordinated and sequenced in the right way. We need to bring production online at the same time as we are converting the grid, the right segments of the grid, and we are converting the end users. So again, similar to the electrification pathway, there is some underlying importance here that we look at the entire energy system. Now, the last scenario, and I'm just going to pick up sort of some of the differences compared to the other one, is a hybrid scenario. There are a lot of variations of hybrid scenarios that look at a mix of technologies or a different distribution of technologies across the UK. In this specific one, we now have 19 million heat pumps. So as I said, closer to the electrification pathway, and out of which about 5 to 10 million hybrid heat pumps, meaning we both have a boiler and a heat pump inside the building. So now that has the advantage that the boiler can potentially, can pick up that winter load, and we see the impact on the generation capacity that is lower than the electrification scenario, but we also potentially introducing more complex in the mix, a sort of a more complex system in buildings. There's also the uncertainty around what type of gas are we going to use in those boilers. Is it going to be something like biomethane? Is it going to be hydrogen? And we need to be able to answer that question as soon as possible, because one of the concerns and challenges with the hybrid scenario is, whilst it's good to have the options for end users to be able to use different systems, it also brings uncertainty. It also brings uncertainty for end users, but also for the supply chain, because they need a low risk environment in order to be able to invest in the new technology. So we have now looked at the three examples of three different pathways to achieve zero carbon. And we've seen that there are both challenges and solutions across the entire energy system, and also the importance of understanding the entire challenge across the entire system. So we've pulled together, having looked at these three pathways, some of the key recommendations that we think they're key that apply for all pathways. It's the fact that we need to demonstrate critical new technology, and that will vary from carbon capture and storage to floating offshore wind. We need to develop the regulatory, market, and risk-sharing agreements to support this mass deployment of complex new technology. We need to make sure that we manage to manage that peak load. We need to upgrade the capacity on our transmission networks, and we also need to focus on end users. We need to have energy efficiency measures, and that applies to every single one of the pathways. We need to deploy as much as possible zero carbon systems now, today, and that is things like heat pumps. We also need to increase heat network uptakes, particularly for strategic sites, and also build end user confidence. This last one is definitely very important, because without end users, we won't be able to reach net zero. And the last point there, we need clarity for supply chains and investors, because without this clarity and certainty, we won't be able to build those supply chains. And on that note, I'm going to end, and thank you very much.